Okay, folks, so in this video, we're going to just review how to solve equations. This was our 4th unit. And what I've done so far in these first examples is I've just dropped that line from the equal sign. The reason we dropped the line is so that we can focus on which side of the equation has the variable. And I wanted to remind you that in this unit, it was all about recognizing what you see with the variable, and basically we're just going to do the opposite, all right? So the variable's on this side, and we have that x is being divided by 7, and when we take away 6, that answer is supposed to equal -4. Now, doing the opposite of what we see here, if our constant is taking away 6 and -6, we're just going to do the opposite and add 6 to both sides. Now that's going to cancel out over here, and we're left with x over 7 on this side. And over here with the -4 plus 6, you're going to have access to Desmos. And so if you're ever nervous about messing up that math, you can certainly just do that in the calculator. But -4 plus 6 is a +2. Now, since we see a denominator, we see divide by 7, we're going to multiply both sides by 7, which is the opposite of the division we see. And over here, we get a 14. And this right here, 7 divided by 7, that cancels out, and x is all by itself. So for this one, x is a 14. Now, the beauty of this unit is that you can, in fact, check to see if your answer is correct. And that's basically by plugging in what we did in Unit 3. You could say, okay, if x is 14, I'm just going to plug it in and do 14 divided by 7. And when I minus 6 here, we're going to get a 14 divided by 7, which is 2. And 2 take away 6, we would be at this -4. So everything checks out. So the answer to the first one is that x equals 14. Now on the next example, x is over here on this side, and what we see is a coefficient, -4, and we see a constant of +12. So our first step, we're going to get rid of the constant. We're going to subtract 12 on both sides. That cancels out, and I'm going to bring down the -4x. Now here, when you have 12 negatives and 12 more negatives, that's 24 negatives. And again, friendly reminder that if you just take the calculator and punch in the -12 and you do -12, it'll give you the -24. All right, now the next step is again to do the opposite of what we see. So when we see a coefficient -4 times x, we're going to do the opposite, which is now to divide both sides by that coefficient. -4 divided by -4 is 1, that cancels out, so we have the variable all by itself. And over here, a -24 divided by a -4 is a +6. All right, and for the third example here, on this side we have the variable, and you'll notice that there's only one thing that we see with it. We see a coefficient. We don't have a constant like we had in these examples. So if you don't have a constant, we have that step that we can basically skip. And right now, we just need to divide both sides by this -0.25. All right, now let's get the calculator. So we've got it was a -4 divided by, so 4, make it negative, and we're going to divide by the 0.25, and again, make it negative. And here we're going to see that that's a +16. So x here is +16. Now, while I have your attention on this example, I'm just going to rewrite it here in green to show you that it could be written with a fraction instead. This -0.25, it could be given to you as a -1/4. And anytime you see a coefficient that's a fraction, it might ring a bell to multiply both sides by the reciprocal. And so over here, if I do -4 times -4 over 1, that is a +16. -4 times -4 is +16. So it's the same problem here in green, and it's the same answer we get. And the reason it's all the same is because the -0.25 and the -1/4 are the same value. All right, cool. So we got x is 16 for that one. Now with this example, I wanted to point out that you have a constant and a denominator, but the difference is that this time our constant is a part of the numerator. So I have these two examples, one below each other, so that you can be reminded of the difference between these two problems. When the constant was all by itself, I started with that. But here, if the constant is part of the numerator, I actually am going to start down here with the divide by 4 and getting rid of that. It might make sense if I cover all of this up and say, okay, so this red thing right here, this red circle divided by 4 is a 5. So I think you guys would agree that this red circle has to be a 20, because 20 divided by 4 is what gives me 5. So the goal is to make this top part thing now equal 20. And so if I move that all away, you can see that it's going to be an 18. because 18 plus 2 would make that thing a 20. Now I'm going to erase that and show you guys the steps here. That again, I'm going to start with this denominator, and if I see the divide by 4, I get rid of it first. And what this shows is now that this top part, the numerator, x plus 2, see how that now equals the 20, which is what we said a second ago, that that top part had to be the 20. Now when we take away the constant from both sides, when we just subtract the 2, here we get x is 18. Whoops, I put that equal sign in there. There we go. And I think you guys would agree that makes sense because again, 18 plus 2 is 20, and then that 20 divided by 4 is what gives me the 5, so everything checks out. So just be careful. If I were to ask you what you see in both of these problems, you would say I see a denominator and I see a constant. But friendly reminder that if the constant is a part of the numerator like this, we actually start here with the denominator. All right, now let's talk about what to do if we see the variable on this side and we've got a constant and then a coefficient here that's a fraction that's also negative. So we always start with the constant. Again, if you see a positive 15, you're going to subtract 15 on both sides. You have your calculator if needed, but 3 minus 15 is a negative 12. And this cancels out, so I'm left with a negative 1/3 m. Now I reviewed up here a second ago that if you see a coefficient that's a fraction, you actually just want to multiply both sides by its reciprocal. Because this negative 1 and this cancel out, and this 3 and this 3 cancel out, so m is now all by itself. So what we did over here, we're going to multiply this side by the reciprocal, the negative 3 over 1, which is basically just negative 3. So if you do a negative 3 times negative 12, we get a 36 for this one. M is 36. So again, in this video, I'm just trying to review all the different types of equations that we learned in Unit 4, because you guys are going to be working on some of these by yourself in a second. And so what this does is just review all the different types of problems that you'll see, and then you can practice on your own. All right, for this one right here, we have an 18 minus 4x equals 58. So we're going to start here by subtracting 18 on both sides. We cancel out and we bring down this negative 4x. And 58 minus 18 is a 40. Now we're going to just divide both sides by a negative 4. And here, a positive divided by a negative gives us a negative 10 for this answer. So it just depends on which side the variable starts out on in the problem. You can kind of see here my variable is on different sides for the answer. That doesn't matter at all. It will matter in the inequalities unit, and that's something that you'll be reviewing in another video. And we've just got 3 more examples here. Now, again, with this one, we only see a coefficient. We have no constant to worry about, so we're just going to multiply both sides by the reciprocal here. And the reciprocal of 2/3 is 3/2. Now you have a couple of options for this 10 times 3/2, because again, this cancels out over here and x is all by itself. You could do 10 times 3, which is 30, and that 30 divided by 2 is 15. You could do 10 divided by 2, which is 5. 10 divided by 2 first, and then 5 times 3 is 15. Or you can catch that the 3/2 in the calculator is just a 1.5. So you can do 10 times that 1.5, and you get the 15. All right, now with this one, if I don't even show any work, let me ask y'all, if we start out with an 18 and we're trying to subtract a number, but our answer turns into a 20, what type of number are we subtracting from 18 for the answer to grow to become a 20? I think already you guys realize, oh yeah, it's going to be a negative number and it's going to be a negative 2. But let's just show that real quick here. If we subtract the 18 on both sides, we have a negative x. Don't forget about the negative with that x. And over here, 20 minus 18 is 2. So we're saying the opposite of x is 2, which means x has to be negative 2, because the opposite of negative 2 is 2. So here, we can see that the answer is that negative 2 that we just predicted. And when we plug it into check, you guys know that when you subtract a negative, that turns into addition. So then the 18 plus the 2 becomes the 20, so we're all good to go. All right, last example for this video. When we drop our line, the variables on this side, we have a negative constant, so we're going to add 5 on both sides. We have a negative 1/4 x that we're going to bring down over here. And over here, negative 1 plus 5 is a positive 4. All right, we have a coefficient, that's a fraction. So we're going to multiply by the reciprocal. And again, anything that's over 1 is just the numerator, so I'm not even going to write it over here so that we can see this answer is going to be a negative 16. So x here is negative 16. So in this video I reviewed, I think that I would say that this problem right here, even though it's a very easy problem, reviewing how to handle that negative x is a big part of the video. I think that reviewing what to do when you see a coefficient here that's a fraction was a big thing to review. And I also think that this type of problem here where the constant is a part of the numerator and then when you have a denominator and how this type of problem is different than this problem right here. So at this point, you're going to flip over now and you're just going to be working on some more solving equations problems on your own. That concludes this video. Thank you for watching.